Today we're working on 9-3, solving quadratic equations. So an equation in this format, ax squared plus bx plus c equals 0, where a value cannot be equal to 0, is called a quadratic equation. Now they're going to reference quadratic function a lot in this section, but it's basically taking the same equation and instead of setting it equal to 0, setting it equal to y. So when we're graphing this quadratic function, you're going to notice that at times the parabola will actually cross the x-axis. This is called the zero of a function. So a quadratic equation can have 2, 1, or 0 real number solutions. So let's take a look at some examples. So in example 1, and this one is done for us, we have 3 different problems. The related functions are graphed below, and we do that by inputting x values into the equation and then simplifying. Again, we're going to use a table to keep all of that organized. Since these are done for you, I'm going to show you how they came up with this. So here is the problem right here. Negative x squared plus 4 is equal to 0. We come up with the related function just by setting it equal to y. So to graph this, you're simply just going to use a table where we have our x and our y values, and you're just going to keep track of them. Now, much like we've done before, I've always told you to choose small values for your x values when you input them in order to graph your parabola. So that's what they've done here. They ended up graphing the parabola, and they found the zeros are located right here, where we have -2 and +2, and those are our 2 solutions. Over here, we have another problem. That is x squared minus 2x plus 1 is equal to 0. To come up with that related function, they just set that equal to y rather than 0. So again, to graph this, you'll keep track of a little table. I would just include your x values as maybe 0 and maybe 1. Again, choose small values to input into this equation to get your y values. So they've done this one for us, and we can see we have an upward shaping parabola, and it only intersects the x-axis in one spot, and that's at +1. So for this one, there's only one solution. Like this one had 2 solutions because it intersected in 2 places on the x-axis. If your parabola does not intersect the x-axis at all, it means it has no real number solutions. So let's go on then and do some. I've used graph paper here, and you can see I've done the entire problem, but we're going to go over it. So here we have an equation, x squared plus 3 equals 0. I did the related function. Again, it's just equal to y now. So basically here are the 4 steps that you're always going to follow. First, find the axis of symmetry. Remember, that is going to be the complete center of your parabola. You can do that by using this simple formula that you practiced last week. X is equal to -b divided by 2a. So keep in mind that this is your a value, which is just 1. There is an invisible 1 there. But now this value right here is actually our c value. The 3 is a c. We do not have a b value. You don't see a value here, bx. So we only have an a value of 1 and a c value of 3. So you're going to see me filling these into the formula. Since I don't have a b value, I put 0. Obviously, there's not a -0, but I'm just going to leave that there for now. 2 is part of the formula. A is equal to 1. So once I've simplified here, I get 0 over 2, or just 0. To find the vertex, we're going to go back to that original equation right there, and I'm going to input my x value, which is 0. So I get 0 squared, which of course is 0, plus 3 is equal to my y value. So that ends up being just 3. So now I found my vertex, 0, 3. I graphed that. I went up 3 and put a point right there, and that is my vertex. Now I can begin creating my graph. 0, of course, is my axis of symmetry, which happens to be also the y-axis. So to create the graph, now I get a lot of questions about this all the time. I think students think that they've forgotten a step here, but these x values are just values you come up with. Remember to choose small values like 0, 1, -1, or 2. Input them into the equation like I've done here to get your y values. So when x is 1, I plugged it into my original equation, which is just what we started with here. So 1 squared is 1, plus 3 is 4. So you see that as my y value. When x is 2, 2 squared is 4, 4 plus 3 is 7. So I've got some other points that I can actually graph on my graph paper. So over here with my graph, I went ahead and graphed 1, 4, which is right there. Then I graphed 2, 7, went over 2 and up to 7. So really I had 3 points graphed, which I then reflected over that y-axis or axis of symmetry. So I reflected this point over and I reflected this point over, and then I drew my parabola. So really you only need to come up with 2 additional points here so you can reflect them over. And again, you want to choose small values for your x so that you can do that quite quickly. Let's take a look at another example. Here's my equation right here. My a value is 1, my b value is 4, and my c value is also 4. Again, I start by finding the axis of symmetry using this formula you learned last week, and I got -2. With x being equal to -2, I plugged it into my original formula to get my y value, which ends up being 0. This is my vertex. The x value is always your axis of symmetry. Now, something I like to do when I graph my vertex is I, at the same time, usually will put a different color pin here marking so that I don't get confused. I want to make sure that I've got my axis of symmetry marked so that when I reflect these coordinates over that I do it correctly. To create the graph, again, you come up with some x values, small values, plug them into your original equation to get your y values, then you can graph them. So you can see I graphed 0, 4 and 1, 9, then I reflected them over the axis of symmetry and connected those points, and I have a nice smooth parabola. Now you can always double check your parabola. This is an upward shaping one. Remember what we said last week about an upward shaping parabola? That a value should be a positive number, and it was, so I know I have a correct graph here. One more example in this one. You can probably just go ahead and follow along. You can see that I ended up with some fractions here as for my x value. That should not prevent you from still completing your graph. So my x value or axis of symmetry is -1/2. You can see I just moved over. It's right in between -1 and 0. When I plugged in to get my y value, that ends up being -2 1/4. So my vertex is -1/2 and -2 1/4. So if you've got to estimate a little bit on your graph paper, you can do that. Now, if you don't have graph paper, just go ahead and use notebook paper and use the blue lines to help you. So you can see that I have 2 solutions down here because my parabola intersected that axis or that x-axis in 2 spots, one at +1 and the other at -2. The last thing we're going to take a look at is sometimes we need to take the square root of each side to find the solutions to our equation. So if you have a problem that looks similar to this one, where you've got 81x squared on one side and 49 on the other, you can kind of follow along with this problem. The only thing that you're going to have to make sure that you're doing is that we have a positive and a negative sign here, and that's because when we found the square root of both sides, this could be a +7 or a -7 and you still get 49, and the same thing with 81. When I come down to this particular problem, you can see that we have to subtract 9 on both sides so that we get x squared is equal to -9. Well, it's not possible to find the square root of a negative number, so this particular problem does not have a solution. So I'm going to leave you today with a few problems to do on the note sheet that I attached. I have the first couple of problems done for you, and then there's a few you can practice in your notebook. Okay, well, I will see you then on Tuesday.